Howdy, I'm Matthew Berry, and for my Chem 117 experiment, I will calculate the specific heat of copper using pennies and a coffee cup calorimeter. These are the supplies that I used. I begin by assembling my coffee cup calorimeter by putting 2 coffee cups inside of each other and a lid to seal. I then prepare my pot for boiling water and grab my 15 pennies that I will be using. I place these inside and put the lid on top. I take 237 milliliters of water and pour it into my calorimeter. Then, I take a food thermometer and make sure to set it to Celsius. Then I place it inside and record my initial temp. I'm already boiling my water, and I will wait 5 minutes to make sure it's properly boiled. After it's finished boiling, I empty the water into the sink and pour the 15 pennies into my calorimeter. I then seal the lid and record the temperature. It slowly rises until it's 26 degrees exactly. For my calculations, I make a neat table to organize the information. There is 1 gram in 1 milliliter of water, so I use that to calculate the grams. Then I multiply the penny's average weight of 1.5 by the amount of pennies I had. I measure the initial temperature of the pennies to be 100 degrees Celsius due to them being in boiled water. As we know, the heat energy of a penny can be determined by the equation heat equals mass times delta temperature times specific heat of whatever material you're using, which in our case is a penny. I rearrange this so that you're solving for the specific heat of a penny, since that is what we're looking for. Pennies give off the same energy as the water absorbs in the calorimeter. So, I solve for the heat absorbed by the water in the calorimeter. This equals, at the end, about 594.96 joules of energy absorbed by the water in the calorimeter. This means that the pennies give off the negative of that same amount of energy. So, they give off negative 594.96 joules of energy. I then plug this back into the rearranged equation to find the specific heat of copper by multiplying in the denominator the weight of the copper I used and the final temperature minus the initial temperature. I measure this to be around 3.6 joules per grams times degrees Celsius. From Google, I find that the accepted specific heat of copper is around 0.385 joules per gram Celsius. So to find my percent error, I plug these values into the percent error formula, getting around a 7.3% error. Thank you, and gig 'em.